Students can have us. Good time. Would be helpful. Okay, so
I saw it.
the primary equation we're gonna be dealing with is momentum. So the symbol for momentum is a P. And your equation is gonna be mass times velocity.
Watch the posters.
Okay, so let's just say, let's start taking a look at we have math 1. Math 2.
Did you see the thing about Terry was here?
They're going toward each other with initial velocity. So then they're going to hit each other. I do that one every year. There's always someone who's like really cool. Now, when they hit each other, they are going to supply forces to one another. Now the slide tells you we're using Newton's third law. So how are the forces, what kind of forces are we expecting?
Equal and opposite.
Equal and opposite. Because at the point they're touching, they're a single system. They're going to transfer momentum back and forth between the two of them. But while they're touching, they're a single system. So we're going to get this equal. We're not worried about how much larger M1 is than M2. We're getting an equal and opposite force. Now, if I write it like this. We talked about this earlier. How do you translate the subscripts on those forces?
The left one is like force 2.
Right. Yes. So you have the F21 is the force of 2 acting on 1. So it's the force supplied to 1 by 2. And so the other one is the force of 1 acting on 2. Kind of getting this idea of these subscripts will be very, very helpful next semester because we're going to have to do this a lot with electric fields in particular. Because this is going to come in important when we start talking about things like superposition. Okay, so this tells us that so Newton's third law. Now, they are going to experience changes in momentum. So usually when two things collide, what's going to happen then? Yeah, they're going to bounce off each other. So of course, you know, their momentums are going to have to change because their velocities are going to change direction. Eventually we can end up solving for those velocities, but why is the change in momentum not going to be, so even though the forces are equal and opposite that they supply to each other, why are the changes in momentum going to be different? Possibly, but we don't know that. What's something that you know in particular, right? What's something you do know right now that would make the momentum change for each one of them different?
The size difference?
What?
The size difference?
Yeah, so the mass. So you can guess that mass 1 is probably larger than mass 2. I mean, unless mass 2 is made of lead, mass 1 is aluminum. But since we don't know, we'll say the bigger one is the heavier mass. Okay, so we can start with Newton's second law. So how did I know to equate mass one and acceleration one with F21?
You're smart.
Depends on the day. Right, so F21 is again the force of two applied to one. So this is really the force that's acting on mass one. So again, that's the force that mass two applies to mass one. Okay, so what's another way we can write this? What can I substitute in for acceleration?
Change of velocity over change.
Glad you got that, because I was going to give you this. That is physics, that is physics shorthand for time derivatives. And that's the second derivative. So. We can do that. Now, why, okay, so velocity is getting a subscript. Why isn't time getting a subscript?
There's only one.
Same time, why? Same system. When are they the same system? When they're touching. So this time interval where momentum changes is the amount of time that they're touching each other. But as we'll discuss next semester, nothing ever actually touches. And all of you who have a significant other and you're like, oh, I gave my significant other a hug. No, you've never actually touched them. It's impossible because all of your molecules are surrounded by electrons. So you always have this tiny little field that separates you from anything else. And the sensation of feeling that you get is just a disturbance of the electrons around your molecules that goes to your brain and a nice little electrical pulse. Yeah, but they're not touching.
Feel my electrons.
You're not actually touching. It's just a pulse sent to your brain that your brain analyzes.
Explain it to me. Says that whole thing, you don't look at you.
But now I can convince Sierra.
Never been touched. You can't touch anyone else. Welcome to life.
What if, like, I stick my finger in Liam's ear, that's still not.
I clean the sink pretty good and like.
No, I-
down here.
His brain that will probably be translated as smack even, so I wouldn't do it.
Like, you're.
I tried to clean up really good yesterday when I. Are you all done then? Your side? You came to help me cut the teeth out and then
You never know how those electric pulses are going to be translated by the brain.
Butterfly.
Like me, sometimes I have selective threat syndrome. It only shows up when I'm really angry or frustrated.
Do I need to start boiling? Keep us like next week.
No, I usually like that little factoid because it depresses something. It's kind of like, when people say, oh, I'm doing really good on my diet. I only had 1,200 calories today. You know that the nutritional calories, the kilocalories, you actually had 1.2 million calories today, but that's,
That's exactly what I'm finding.
Down here.
now everyone's going, oh.
So you had over.
I don't count my calories.
Yeah.
Don't need more.
That's what I was saying.
Okay, so
1,000.
what we can do next,
Not pickles.
is we can say that go ahead and split these apart. And we can also say that yeah, looking at for this second one over here. What can I replace F12 with? In particular, I can replace it with F21 now. Yep, negative. Equal and opposite forces. And I know what F21 delta T is. So that means okay. And so now, even though we know that the changes in momentum might be different based off the masses, our first statement that momentum is conserved in a system, there is a caveat to this. Our first statement that momentum is going to be conserved in a system is these two equations will translate to the change in momentum of mass 2 and equal to negative change in momentum of mass 1. Now, let's talk about units for your momentum. What do you think the units are? Yep. Mass velocity, mass velocity.
I think.
Yep, kilograms meters per second. And that's just gonna be your unit. There's no fancy unit for it, like, you know, last time we had the watt. This one is just kilogram meters per second. And that's it for me. You guys finish the chapter and I'll give you a test on it.
How about it's just it for the day? We just keep going over.
Actually, please, that'd be so kind. That's how we.
Wouldn't you like a map?
I think you're responsible for the rest of the chapter. I mean, you're responsible for it, not.
No, we.
Yeah, but
Pick it up.
you know how well we read the book.
Okay,
On you, go, who doesn't know physics?
so let's look at a problem. What is the momentum of an apple weighing 1 Newton just before it hits the ground if it falls out of a tree from a height of 3 meters? Okay, so
She's that specific.
what do you think we're looking at here? Apple starts at rest, it has a final velocity. That's gonna be what?
What?
Yes, the problem tells us.
An apple isn't moving and then it's moving.
Right, so that's gonna, so how are we gonna, is it gonna be P equals MV or is it gonna be?
What?
If it starts with 0 velocity and ends with a final velocity,
Whatever your source matters.
yeah, it's change in momentum. I would have hoped you would have noticed a system where you have a change in a physical property by now.
I'm so tired. You're so bad.
But
Actually.
since initially it's hanging from the tree,
No.
that's gonna be 0.
But it's like. Need buffers, we too. So you know how we did the pipe.
So we're gonna be solving for
That's their part. Buffer. Oh, except put these 2 extras in.
the change in momentum. So we need a mass and we need a velocity. We have a weight. We have a distance that the apple fell. How do we find a mass and a velocity? Oh, so what's this number here? Newtons, and that's the weight of the apple.
And that equals mg.
All right. The first thing I can do,
Yes.
well, the mass of the apple is going to be by gravity. Newton divided by 9.8 meters per second squared. This is going to be 0.102.
Maybe mention it.
kilograms.
In the background.
Now, what about the final velocity?
We have the height.
What are the
Is it a kinematic?
kinematic?
Boo. I hate kinematics.
You know I did.
You're saying today's assignment should go back a few chapters and be all kinematics.
No.
Yeah.
Oh, okay.
We can't say that. We'll write a report about it.
This is the one I picked. We don't have a delta T, so we can't really use any of those kinematics.
Send me a picture of the notes. Yeah. Dental lead.
I thought about it, but there's just no fun in that.
Wait, you thought about what?
You really need to like get out of your house or something. Have fun and.
Oh, that would mean interacting with people. That's big now.
Play some video games, drink a beer tonight, everything will be fine.
It takes all the energy I have just to get out during the week.
Yeah, me too, I feel that.
You know what takes all my, doing the civics design.
Great, you're gonna be exhausted this weekend.
I don't do it this weekend. Well, next week.
Go
So
yet, I'm not done yet.
So we get rid of the initial velocity. We would have -2
Site,
G. Why?
I did do it right. I did it wrong.
No, really.
So funny.
So your final velocity,
They're like, I wonder what's the.
Wait, why is it negative?
-G.
Oh, yeah. Wait, what?
Yeah, I do.
Okay, because your delta Y, your Y final is 0, that's the ground. Your Y initial is 3 meters, so your delta Y is a -3.
Better than her saying you're a god.
So our final velocity,
Doesn't give you anything.
I don't like a lot of.
I think she. What was it?
11.67 meters per second. So now we can solve for the change in momentum.
Yeah. Because every chart.
Change in momentum, there's gonna be -2. Kilogram meters per second.
That's crazy.
I might have to. Stuff.
No.
Wait, I'm not ready.
For the better.
No, we still have to do part.
Oh.
Well, I did write
Oh, part B.
Wait.
I wrote so much.
The apple falls because of the gravitational interaction between the apple and the earth.
No.
How much does this interaction change the Earth's momentum?
Nothing, not
How much
enough.
does it change the Earth's velocity?
None. It's probably gonna be so minuscule that we can't even. You can round up to 0. Yeah.
So this
Or
goes
down to 0.
like that.
No, gravity, they pull on each other.
Oh.
That's why-
But Earth.
Huh?
Earth.
Obviously.
Oh,
I know, but still,
nothing. It's gonna round to 0.
it's gonna be tiny, yes.
Is that like an acceptable?
Tiny.
I would say according to Keith rules, that is so much smaller that we can just call it 0.
I want you to tell me the change in momentum of the Earth without your calculator.
0.
0.
Keith said 0. No,
Oh.
since if it's small enough, basically
just
0.
round.
Unless it's
want.
Keith
Unless
rules,
it's one.
if it's so small, you just ignore it. You don't even say it's 0, you just ignore it.
Doesn't matter.
Ignore it. It's gone. It's gone. Ignore it. It's so minuscule.
Change in
Ignore
momentum
it.
of the Earth. Apple.
In this circle.
Or he would go 0.00000000,
He
and
would
then
do it, he would do it on the board and then he'd be like, you don't need to do this,
So it's
it's
the
too small.
ignore it.
So it'd be the negative.
That's why we
of the
didn't get very far.
Yep.
Okay.
So,
Yeah, teach us how to do things. We don't have to do this.
so the change in momentum of the earth is gonna be a negative 0.72 kilogram meters per second. So when the apple falls, it's towards the earth, when the earth moves, it's towards the apple.
You know that method, I wrote that.
This is a really good argument for all the Chuck Norris jokes.
It took me forever.
Every time he does a push-up, he actually moves the earth.
I thought you were talking about the shot for a second.
It's a real person, Taya.
You need the shot.
You've never had a Chuck Norris shot?
No.
Normal people call them cherry bombs, but Shadron people call them.
No, I knew them as Chuck Norris's back home too. It's Cherry McGillicuddy's and blue ice flavoring. Yeah, and they're so good. Go order
I'm
one.
talking about the Chuck Norris jokes, like underneath Chuck Norris's beard. it says,
Yeah, he didn't know it was a real person.
Literally.
I just know the alcoholic shot.
Okay, so now the change in velocity.
Bobbed.
Let's start with,
A juice and not a mixer.
When I woke up.
Oranges, you're like, oh, it's a screwdriver, no. it's just a mixer.
Then-
Oh my gosh.
change in velocity of the earth is going to be the earth's change in momentum over the mass of the earth.
And you know that?
Yeah, because momentum is mass times velocity.
No, I mean, you know the mass of the earth?
Yeah,
Fine.
you look it up on the internet. ChatGPT tells you.
Saying, how do they know?
Do they have a giant scale?
Yeah.
I feel like it's just made up.
If you really want to do part of a semester on
Oh, I
the,
already asked you this, but I started, but I'll let you.
look, it's all orbital mechanics, gravitational interaction. Shapes of the orbits, we look at the exact elliptical patterns of each planet around the sun. You can start to generalize masses of each planet.
See, and in my mind, I imagine you guys.
That's why there's not a physics major at Chapman.
If you want to, you can do it.
I don't want to do it. What's the mass of the earth?
Okay.
We just say it weighs like 10 pounds.
Doesn't feel like a lot. Oh, that is a lot though. 10 to the 24th?
That means.
Way heavier.
Make it.
Yeah. I think so.
We're doing good there.
So the Earth's change in velocity
Like I said, actually.
Looking heavy.
and we are not gonna round that to zero.
But you said Tim rules.
No, I didn't. You said Tim.
Oh,
No, I said Tim rules solved the first part of that with no calculator.
Hey, what if we throw a Rolo at you? That's like the momentum of the Rolo.
I don't know if that's just because you think you can throw something at me, or if that's because you think I'm fat enough. Looking in the right direction is gonna bribe me. I don't know where you're going with this.
Maybe the second.
Do you
I'm
want
not
the
gonna say
Rolo?
I'm not tempted by the Rolos, but we have stuff to do.
it's like a chocolate with like.
Pretty good.
I don't think I've ever had one.
So I.
Last class is weird.
They eat more directly.
Only glass I'm gonna.
No.
So you're-
I don't
Oh, I've
think I've
never
ever-
had a donut before.
You know what, Mike, you really have this.
That's what you sound like, yeah.
Okay.
Oh.
Yeah, and I-
It's called impulse momentum theorem. Now, in all fairness, we're talking about the
Fast.
physical construct called impulse. I was gonna make a Star Trek joke, but I realized nobody would get it.
My,
Hey,
Jay equals chain.
you're forgetting about these people.
I watched all
Jay
of
equals
this.
fat. She's calling you fat.
You're the
Jada.
only one who would have understood impulse joke using Sardra.
But,
Speed.
but.
You're
are you
calling
me
Jada fat.
Are you calling me fat just cause I ate the Rolo?
J equals fat.
This is like when we get PV equals in our team.
Pervert.
You guys suck, you really do.
I'm not the one calling me fat.
You wanna go something else, cheer you up? I'm going to short you tonight to a party.
Oh, nice. Yeah, yeah. You know, I still have a bit of memory of the first year when I put up the ideal gas law. PV equals NRT, Jana hasn't been paying attention. So she goes, "Oh, perfect." That's not what it says.
Jay wasn't being bed bugs.
All I mean is you're not.
And he dressed up as him for help.
It's not fact. It's Delta T.
The show for me.
Oh.
Go as you should.
I was Chin. No one knows
We can
Chin.
really pack the fact that you thought of.
Chin.
you.
Yeah.
Since nobody said anything about you.
Nuh-uh, she
in
said
your
it.
head, You're like, was it directed at me?
She
This
said it.
hints
I noticed
at
it, so I had to tell Jana to get triggered.
See, that's what it's saying.
internal insecurity, right? What's on the slide?
Yeah, actually, she said it actually doesn't mean it, because I said he's calling me fat, and then Kiana says, no, it's a J, and I said, oh no, Jana, he's calling you fat.
J is a symbol for impulse.
I'm never.
Look, every Rolo you eat changes your momentum, so yeah, it's an impulse. So
They go to me still.
the way to think about impulse is an object has momentum. You apply an external force to that object, changing that momentum. That's an impulse. I'm gonna go home this weekend and take a bunch of Tylenol, maybe I'll remember.
Hey, you're gonna get an autistic baby.
Okay, so. So we can, in a generalized format, because, you know, objects can have multiple forces applied to them. Okay, so the first thing to take account of
Kevin was like, yeah.
Where?
Yeah.
is that, okay? So we're gonna be looking at momentum changes.
Maybe my drink. Sweet tea.
We're going too fast.
We can have multiple momentum changes,
So much ego. Slowly. Extra 20 pounds.
which is gonna lead to, a sum over impulse changes. So we can say this is gonna be like F1 delta T.
Going in March
And so on and so forth. So what this is going to give us,
Yeah, no.
the total impulse of a system,
Make a lightsaber.
We'll have a one.
we're gonna get that, which means, yeah,
I'm gonna hate you guys so
No
hard
question.
for that.
I'm
just gonna-
I'm gonna beat you guys with my
Is a
list.
lightsaber cooler than a?
Would you rather? Or a magical wand.
Which one can kill you?
You can't.
Which one can kill you? I'm one.
Do with the lightsaber
Just
is slash someone.
so much with the wall.
Vatican abs.
Darth Vader has the lightsaber to do this.
There's probably. Take your wand into lightsaber. Like, if you think about it,
Never watched Harry Potter, so that's why I do want the hottest one.
Okay, so,
Sorry about that. I just couldn't. I appreciate your opinion. That guy has a master's, a PhD, and he says a lightsaber is better.
Still be-
So,
Yeah.
Right.
I wasn't fighting about this, I just want to
Well,
like.
might be freaking out.
He only wants
So
to
you're
like
saying
because he's a
crap.
nerd.
I feel like if you're neurodivergent, you're probably a wizard or a witch, you know?
Oh, you don't call them witches.
You call them Jedi.
I said, I'm just gonna beat the crap out of them. with my lightsaber.
Call them which they get burned at a stake.
That is.
Let's be clear.
Wait, I have a joke.
Yeah.
Or red.
Wait,
Food.
what's the difference between Iron Man and Iron Woman?
You need a.
No idea.
One's a superhero and one's a command.
The what?
Looks like the one.
Oh my gosh.
Not touching that one with the
I saw that one on TikTok today.
You should do the method.
That's kind of like that TikTok thing.
Have it mixed
I
with
just, we're not.
I gave Bella a
But
hug.
I am just a girl.
PDF or.
So we talked yesterday in my class about girl math.
I did.
Girl math is so smart.
This guy over there was like,
Yeah.
if you use cash, it doesn't count.
So the total system is going to be the
So much worse.
acting over a given period of time. Well, since we've been working with that, it's easier to us.
Yeah.
Oh, yeah.
I would
Do you pay for premium?
see exactly. What you guys are gonna be there. What is Star Wars?
Saved me in calculus.
Oh, I can forget about
For sentiment jar. Some sort of, yeah.
Red forces are not
that.
constant.
Kylo Ren.
Wrestling. Knew a year ago. And I looked at it.
What church? Oh.
I-
What is bowling? I'm gonna.
Alright, got it.
My corner.
When your forces are not constant, you're gonna be looking at a sum of your average
It's a
forces.
butter.
Yeah.
Basically, your average force in the system.
Like that stuff.
Across the sum of T,
Take it.
yeah, average.
Just imagine all of us coming flying back with our license.
That's the way.
Thinking of broom, like,
Right.
back.
That's
Fly
exactly.
back to Nebraska.
Or like, hold on, I'll show you.
All these fucking nerds showing up from Florida. Yeah.
This is particularly
Already.
for a system where the forces are not constant.
You hate me, it's because we haven't watched your.
Okay.
You don't understand.
Wait,
Baseball catchers catching a fastball that is thrown.
scroll just a little bit back.
She needs up.
Can you just scroll a little bit back?
So 33 meters per second, my athletes, is that a major league pitcher, high school, college? What are we looking at there?
43 meters, there's.
That's really fast.
Yeah. That is.
Yeah, that's.
East. Yeah, 43.
Because
That is probably her name. She's like,
It's about 96 miles per hour.
that's 96 miles.
I know, it's like pretty okay. I'm pretty sure they throw higher than 100.
Who cares? I don't.
Yeah, 96 is, that's pretty good.
Pretty good.
Pretty good.
It's not the fastball you might get hit by.
No.
Yeah.
If the mass of the ball is 0.15 kilograms and the catcher moves his mitt backward towards his body by 8 centimeters as the ball lands in the glove, what is the magnitude of the average force acting on the catcher's mitt? So imagine the ball hits the mitt, you're going like this. You're increasing the amount of force hitting your mitt, but the forces are not gonna be constant because you're moving. Technically, as the ball loses momentum, you're still moving backwards, you're getting less and less force at each differential. So what is the average force on the catcher's mitt? What is the time interval required for the catcher to move his knee?
97.
Yeah. Actually going to.
Okay, so now I want you to pay attention to this one,
My cousin asked for.
because this one's a good example of, like, if you were using AI as a tool to solve this, it can give you a solution. However, the solution it gives you when you take a points off.
That means what it gives.
When I checked this with AI, what it did was it gave gave an average velocity, saying that the velocity after the catcher fully catches the ball is 0, the initial velocity is 43 meters per second. He gave an average velocity on the average force.
Every time I
the
go-
VI is zero.
Well, we're not even worrying about the batter right now. The problem is we haven't worked out a problem like that, so you're gonna have to figure out, for example, the time over which the catcher is catching the ball in a different way.
They keep expanding.
So again, when you're using AI as a tool, don't just put down what it gives you, because it's a kind of solution we haven't done in class, you will lose points.
So is VI in this instance?
We don't know.
You don't know?
You know nothing about, initial is 43.
Actually float out.
Oh, okay.
But final velocity, you don't know, you have no
Exactly,
idea.
this is where.
Oh,
we know
yeah,
it's
I
gonna
agree.
be.
Oh yeah, AI does give you the wrong answer.
Assumes that the final velocity was 0. Once you're doing
Well, I need better.
Florida.
So, what do we know about average force?
An educational.
It's the force over the whole period of.
Like if there was a flame.
Okay, now, we're gonna talk about how you would solve this in a way different. Because AI can give you a hint. But you need to think about this and solve it in a way that you. Okay, so
I can do it too.
we know,
Down a hill.
well, actually, yeah, we can assume that the final velocity is 0, but we're not doing that. We've never solved anything that way. So what's another way we could solve if the catcher's moving his mitt over 8 centimeters? What's another way we could solve this? The time over which the ball initially touches the mitt to the point at which everything stops. In a matter. So what we would do is we would say, because you see here, to solve this, we need delta t. So what we would say, I chose this one. I chose this one. You can't actually assume that at the very end, once the catcher stops moving, everything's at 0.
So did you just say that you're assuming that VF is 0?
Yeah, see, I changed that while you were talking.
I was talking about something important.
Were you?
But it's still not.
Okay, so
They can say, I don't really.
then from here, what we do.
Yeah, but I said that and then this point, pressing up.
We solve for delta t and we get 2 delta x VI. I'll show you what AI did. AI said you have 2 velocities.
No, I just.
So velocity 1 could be your final velocity, velocity 2 could be your initial velocity. And we did velocity 1 plus velocity 2 over 2. It did an average velocity. We've not solved anything that way. That's not intuitive. That may get you the right answer in this circumstance, but won't at this time.
Nope.
So again, you would have to translate what AI did into something that we've done in class. So we would put in 2, delta x,
Betty since birth.
0 meters, 43 meters per second. We get a delta.
I don't know who that
0,
was.
0, 0.
Not here anymore. It wasn't me.
372 seconds. Okay? Okay, so we'll finish this up, on Monday. But again, this is a good example of AI can be a guide. Make sure you're translating it into something you've done in life.
Alright. I just showed them. Well, I thought I was making it. Oh, absolutely.